Hey there, and welcome. Have you ever felt like your own health records are locked away in a vault somewhere, and you just don't have the key? Well, you are definitely not alone. Today, we're going to pry that vault open and dive into the amazing world of health informatics. You know the drill, right? You go to a new specialist, and it's like you're starting from square one. Your family doctor has one piece of the puzzle, the hospital has another, the specialist has a third, but nobody seems to have the whole picture. So why? Why is our health data so scattered and locked up? Well, it all boils down to what experts call the healthcare data problem. Right now, every single second, we're generating just a staggering amount of health data. It's like a digital flood, but without any way to organize it, it's really just noise. And that is where health informatics steps in. You can think of it as the science of turning all that data chaos into real clarity. It's this perfect blend of computer science and healthcare, and it has one big goal: to make sense of all this information so we can make better, faster decisions about our health. Okay, so how do we actually fix this mess? What we need is a common language, a language that every hospital, every clinic, and every lab can speak fluently. We basically need a universal translator. And that translator has a name, FHIR. That's FHIR, and it's pronounced FHIR. Now, people have tried to create standards like this before, but they were usually way too complicated or rigid. What makes FHIR so different is that it's built on the exact same modern web technologies that power the internet you and I use every single day. This lets all those isolated systems finally talk to each other. And listen, this isn't just some academic theory. FHIR has some serious muscle behind it. The biggest names in tech, we're talking Google, Microsoft, Amazon, they have all thrown their weight behind it. And you know, when those companies all agree on a single standard, it is going to be a total game changer. So how does it actually work? Well, think of it like Lego bricks. FHIR takes all this complex health information and breaks it down into small, standardized pieces called resources. So you have a little blue brick for patient, a red one for diagnosis, a yellow one for medications, and so on. Each brick is this simple, understandable piece of the puzzle that any system can immediately recognize. So how do these systems swap those Lego bricks back and forth? FHR uses the same kind of modern web technology that lets you order food or watch a movie on your phone. It allows one system to send a super secure request for just the information it needs, and the other system sends back only those specific blocks. It's a clean, secure process built for today's internet. And once you can connect these blocks, you can start to map out entire healthcare journeys. A request, like a doctor sending a referral, can trigger an event, like scheduling an appointment with that specialist. This is how different systems can finally coordinate complex care, making sure your treatment is seamless, whether you're getting a lab test or a new prescription. Okay, so we've talked about the techie side of things, but what does all of this actually mean for you, the patient? How does it put you back in the driver's seat?
It means exactly this. For the first time ever, really, you can securely get your complete medical history. We're talking lab results, medications, diagnoses, the whole shebang, right on an app on your smartphone. The key to that vault, it's finally in your hands.
And the process is actually pretty straightforward. First, you give an app you trust permission. Then, that app sends a secure FHIR request to your doctor's office. Their system finds the right data blocks, your information, and zips them back to your phone, where you can see everything in one place. And the most important part, you are always in control.
But here's the thing, getting your data on your phone, that's just the beginning. The truly revolutionary part is what happens when we can start to analyze all of this newly connected data at a massive scale.
All of this clean, standardized data becomes the rocket fuel for the next generation of medicine. It's the raw material that's going to power incredible breakthroughs in artificial intelligence and machine learning, letting us see patterns and find insights that were frankly impossible to spot before. And the possibilities here are just breathtaking. We're talking about predicting disease outbreaks before they even start, using AI to analyze medical scans with superhuman accuracy, giving doctors AI-powered tools to help them make better diagnoses, and even recommending personalized drugs based on your unique health profile. It's amazing. Now, as incredible as this future sounds, we've got to be realistic. This is a huge, huge transition, and there are some pretty significant hurdles we still need to get over. You know, turning this vision into a reality for everyone, it's a massive undertaking. Getting every clinic and hospital on board, updating ancient computer systems, and just agreeing on the rules of the road. That's going to take a ton of investment, collaboration, and frankly, a lot of hard work.
And these challenges come from all sides. You've got the financial hurdles. This stuff is expensive to set up. There are technical problems with old systems that just don't want to talk to new ones. Of course, there are massive privacy and security concerns we have to get right. There's even a human element, like getting doctors and nurses trained and comfortable. And on top of it all, a lack of clear rules and funding can slow everything to a crawl.
Which, brings us to the final and maybe the most important question. As we build this incredible new world of data-driven medicine, the biggest challenge might not be technical at all. It might be about trust and control. Who gets to write the rules for how our most personal, sensitive information is used? Who's in charge? That's something for all of us to think about. Thanks so much for joining me.